Okay, we're going to look at something that's pretty important. It comes up in most all exams, and it's something called the nature of roots. We have this quadratic formula here, minus b. We found the roots of a quadratic equation are equal to negative b plus or minus the square root b squared minus 4ac all over 2a. Well, there's this special thing called the discriminant. The b squared minus 4ac part of the quadratic equation, we use a Greek symbol delta to equal b squared minus 4ac. It's so important because what we know about this delta can tell us about the roots. The discriminant is the expression under the square root. Okay, so that b squared minus 4ac, that's the discriminant. You can determine the nature of the roots. Well, what do we mean by nature? It means the different types of roots. Now, the roots can be real numbers. They can be non-real numbers. Non-real means like the square root of a negative number. That's what a non-real calculator will say error, but it means non-real. It's not undefined. It's just non-real. The roots can be rational. Those are roots where you take a square root and you get a rational number. You get a integer, when you take a square root there and you get an integer. And irrational means you take a square root and it just doesn't work. So it doesn't equal an even number like that. And the other thing, that can happen is this b squared minus 4ac can be nothing. And so you're adding and subtracting nothing. You really only get one root. They're both equal to each other, but you just get one root. Now I want to take a look at it a little bit carefully. Here are the 5 types of roots. If they're real, if the discriminant, if the thing in the bracket is just a positive number or it's 0, you can say the roots are real. If it's negative, you say they're non-real. If it's less than 0, any negative number here you get, it's non-zero. If it's a perfect square, if the number's a perfect square, when you take the square root, you get a rational number. So your number is, your roots are rational. But if it's not a perfect square, if it gives you an irrational number, then you've got an irrational roots. And if it equals 0, the roots are equal. You've actually got one root. Here, on just what I've said here, I put it in words here so you can look at it a little bit carefully. If delta equals 0, if it's equal to 0, then there are 2 equal roots, which kind of means the same answer. Okay, I put this little thing in here in the notes so that you can take a look. If you made a parabola out of the quadratic equation, if the roots are non-real, it means x doesn't equal 0. It's a parabola that's not touching the x-axis. That's what's going on. That's if b squared minus 4ac is negative. That's the kind of picture of the situation. If the delta is equal to 0, then you have one root. And if it's a parabola, it's just touching the x-axis in one place. If we looked at it and we graphed it. But if the roots are real and unequal, they could be rational or irrational, but what you've got is a parabola that's cutting in 2 places. It's cutting in 2 places. That just sort of helps. I think the parabola helps you to see the roots or think about them. Okay, let's look at how we do this now. We want to show that the roots of an equation are irrational. You're supposed to show that. Well, all you do is you write down the quadratic equation, make sure it's in standard form. A is 1, B is 5, C is 3. Then do the b squared minus 4ac. So it's 5 squared minus 4 times 1 times 3. 25 minus 12 is 13. Well, 13 is not a perfect square. If I take the square root of it, I get an irrational number. So there are going to be 2. I'm going to be adding an irrational, and I'm going to be subtracting an irrational number in the answer. So there's 2 unequal irrational roots. If you can't take the square root of it, it doesn't equal an even thing, then the roots are irrational. They're real, but they're irrational. Okay. Well, let's look. Here's three questions here, just looking at them quickly. Say you had x squared minus 4x plus 4. All you do is you go a equals 1, b equals minus 4. That's just not supposed to be there. That's just a little bit of a mistake, but I can put it in right now. That 5 is not supposed to be there. B is equal to minus 4, and C is 4. And all we do is we put it into the b squared and minus 4 and say minus 4 squared minus 4 times 1 times 4, a times c. We get 16 minus 16, we get 0. If delta is equal to 0, we say the roots are real and they're equal. There's actually only one answer, but the roots are real and equal. Let's look at this one, x squared plus 3x plus 4. Well, a is 1, b is 3, c is 4. There's your b squared, 3 squared, minus 4 times 1 times c, which is 4. We've got, this should be 3 squared. It actually equals 9. I'm going to get rid of that. A couple of mistakes in here, so we got to fix that up. It equals 3 squared, which is 9, minus 4 times 1 times 4. That's 9 minus 16. That's a negative number. B squared is 9. Minus 16 is a negative number. Now, when you take the square root of a negative number, on your calculator it says error. The roots are non-real. Non-real. Let's try this last one. Okay, there's a is 2, b is 7, c is 6. B squared is 49. 4 times a times c is 6. So that's 49 minus 8 times 4 times 12 is 48. 49 minus 48 is 1. But 1 is a perfect square. You can take the square root of 1. It equals 1. Therefore, you'll have two equal roots. The roots are real and irrationals. Okay. Well, hopefully that'll help you when you go to try these questions to determine the nature of the roots.